Okay, so number 12 is kind of hefty. These are not as quick as some of the other problems that we've done on this test review, but it is dealing with factoring, and remember, we will not have a calculator for this test, so we want to make sure that we are really well versed with these factoring strategies. All right, so let's go to them again. It says factor completely, and then we're going to find all the exact zeros. So the factoring part means we're going to get them in parenthetic piece forms, and these exact zeros means it's going to be x equals the numbers all listed out here. Okay, so let's go ahead and begin with A. So I do have a trinomial, and because we're finding the zeros, we're going to set it equal to 0 and go ahead and go with our strategies as far as factoring goes. Our number one strategy is always trying to first GCF everything out. Of course, this is after we set it equal to 0. So whatever the equation is over here, set equal to 0, we're going to try to GCF. Is there a greatest common factor that we see between x to the fourth, 14, x squared, and 49? The answer is no. So because there's no greatest common factor, we're going to go immediately to our two pair of binomials that we're going to methodically factor out. These first two terms will multiply to get me an x to the fourth. Okay? Yes, they could be x and x to the third, but primarily our first go-tos should be the ones that are basically kind of closer together. Okay? 3 and 1 are a little bit further apart than 2 and 2. So we're going to start with x squared and x squared. And then we're going to concentrate on the last term. Okay, so the last term is a 49, which now these two terms will multiply to get a 49. So this is a positive 49, meaning I will have 7 and 7 both be negatives, or 7 and 7 both be positives in order to get me that positive 49. Okay, remember they are multiplying to get this 49. So let's go ahead and put the 7s, and now we just have to line up our signs as far as are they both negative or are they both positive. Well, in this case, they're both positive because the inside terms, which is a positive 7x squared when you multiply, and the outside terms, which is another positive 7x squared when you multiplied, will result in our b term. And that b term is the sum of these two, which you see right here as 14x squared. Okay, so yes, if you were to FOIL all of this out, you would get that original p of x polynomial that we were given right at the beginning. Okay, so now that we have them factored, we're going to factor as low as we can and then find the exact roots. Okay, so because of the fact that we recognized at the very beginning that this was to a power of 4, we know we should have 4 groups of parentheses. Okay, set equal to 0. And just like our notes, with sum of squares, this x squared plus 7 becomes the following. X and x would multiply to get this x squared term. And then now I need to take the square root of 7, which you'll have root 7 and root 7. But because this is a sum of squares, we know each of these root 7s are going to have I. Okay? They still, just like a difference of squares, will have a plus or minus, because if you were to FOIL all this out, you would get back to the x squared plus 7. Okay? And because this is identical, you're going to also have x plus I root 7 and x minus I root 7. Okay? You could write I root 7 like this. Some people want to write square root of 7 times I. I tend to have my students lend more to this because otherwise sometimes they think that the I belongs underneath the square root, which is not the case at all. So that I root 7 is a preferred notation. So these are now the completely factored forms that I'm now going to solve for when it comes to what are the exact zeros. So x is equal to, this one set equal to 0 is going to be a negative I root 7. This one set equal to 0 is going to be a positive I root 7. And again, you could do this as 7 root I with a negative or positive root 7i. Just my preference is to put the I in front so that it's not confused with being underneath the square root. But either one is correct. Okay? Just make sure you don't show that it's underneath the square root. So now let's find, this one is the negative I root 7, and then this one is going to be the positive I root 7. So basically a multiplicity of 2 on each one, but you can list them all out if you wanted. Okay? So I have 2 of these, and then I have 2 of these. So you could, if you want, just put x is equal to plus or minus root 7i, or plus or minus I root 7. Okay, and that'll account for all 4 of them. So like all 4 of them could be all right here. Okay, now let's go to B. B has 4 terms, and a good process to go through this, of course, the first step is GCF. None of them have GCFs, like there's nothing in common besides 1 that they all share as a factor. So we'll just go ahead and set it equal to 0. And then whenever there's 4 pieces, a good strategy that you can begin with is to kind of factor these out with pairs using another GCF. So the first GCF in that x cubed minus 7x squared is in fact an x squared, which you would have left over an x minus 7. Okay, all we did is that we GCF'd out the biggest, greatest common factor that these two shared. Now we're going to do the same with this piece over here, and it looks like it's going to be a positive 4 that we're going to pull out. Okay, that means what we divided out and was what we were left over with is going to be an x minus 7. And these two, basically 2 of a kind, this pair, shows that this actually did work. Sometimes this method won't work. If you don't get this 2 of a kind pair, that means that factoring with that GCF, it's almost like factoring by grouping method, didn't actually work out. But in this case it did. So we have an x minus 7 that we will write just 1 time this time. And the outside of parentheses pieces get written as the other factor. So we have those, and again, we can always look at this degree and know that we're supposed to have 3 sets. Because it's to the power of 3, we're supposed to have 3 sets of parentheses. So here we do see a sum of squares. That sum of squares, just like we learned throughout the unit, is the x plus something and the x minus something. And then the other thing we have to be careful with right here is that taking the square root of 4 gives us 2i and a 2i. Okay? Why do we have the i's instead of just 2's by themselves? Because these i's end up taking care of the fact that this will become a sum of squares. Okay, so now the x minus 7 factor, that's just going to be moved down. So now this is factored out completely, and my x-intercept exact zeros are just going to be listed as x is equal to a negative 2i, a positive 2i, and then a 7. Again, remembering that these x-intercepts are what would be replacing x on each of these to make that whole piece individually equal 0. Okay, so now let's go to C. So C has 3 terms. There's no GCF. Again, always going with that GCF. So because we have 3 terms, we're going to go with setting it equal to 0 and looking for the 2 pairs of binomials. So we need these 2 first terms. Okay, let me highlight them. We'll again multiply to get x to the 4th. Let's keep it close together by doing x squareds on both instead of x cubed on one and x on the other. And now we're going to concentrate on our last term of negative 9. So 3 and 3 will give us that negative 9. So I got to be careful with what I'm choosing because 3 and 3 do give us 9, but also so does 1 and 9. Okay? So this is where a lot of number sense comes into play. If you can have your multiple facts really memorized in your head pretty quickly, without the aid of a calculator, this works very, very cleanly as far as figuring out which one should we use. Should we use the 1 and 9 or should we use the 3 and 3? Well, let's add these two. We get 10. If we subtract those two, we get an 8. Over here, if we added those two, we'd get a 6. And if we'd subtract those two, we'd get a 0. Okay? What I'm looking for is trying to find this number here as our b term, which is an 8, which I see right here. And that only happens if I'm using 1 and 9. So let's put 1 here, let's put 9 here. And last but not least, we just have to figure out where do the negatives and where do the positives go. Okay? I'm going to put a negative here for 9, and I'm going to put a positive here for 1. Because let me highlight this. This positive 1 will multiply with negative 9 to give us that negative 9 that we needed. Furthermore, this positive 1 will multiply with x squared. That's the I piece in FOIL method. And then the outside pieces will multiply to give me a negative 9x squared. Okay? So if I have both of those for the inside and outside pieces, they do in fact add up to this negative 8. So those are the factors. X squared plus 1 and x squared minus 9. Okay. So now let's look at how do we further factor this. Because again, we want all these factors down to x plus something or x minus something. So this 2 as a power tells us we still have to break this up. This 2 as a power tells us we still have to break this up. So now we have 4 parenthetic pieces, which this leading coefficient's degree, or this leading x degree of 4, told us that we would in fact have 4 sets of parentheses. So this first one here is a sum of squares. So you have x and x, plus and minus. And now we just have to take the square root of 1, which we get 1. But again, with sum of squares, when this is adding, we need an I there. So this is actually 1i on both. Difference of squares, we don't need that I piece. That one's a lot easier to where we don't have to worry about this I. So it's just x and x. This difference shows that this will still be positive and negative. But because of the fact that this isn't a addition, a sum of squares, we're just going to do a difference of squares, which means take the square root as you see it all by itself. No i's are involved. And the corresponding x-intercepts are negative I, and then this one positive I. This one is a negative 3, and the last one would be a positive 3. So those are the x-intercepts, or exact zeros, and these would be the completely factored pieces. Last but not least, let's do D. Let's go straight to that GCF. We are setting this, of course, equal to 0, but at the same time, I'm going to factor out from both of these, and I'm going to write right here in front of this equal sign, their GCF of x. That leaves us with x to the 4th minus 16 in the middle, okay, or in the parentheses. So this x right here is already factored, so I don't have to touch that. But what I do have to concentrate on is this x to the 4th minus 16. Now this is a difference of squares. So x to the 4th minus 16 will break up into 2 sets. Take the square root of each piece, and it's basically x squared and x squared, and it's 4 and 4. Again, just a reminder, because of the fact that this is subtraction, we're not going to have i's here. That's only with the sum of squares. So with this being a difference, we're just going to make one positive, one negative, and we've just factored it. Furthermore, this will factor into 2 pieces here, and this sum of squares will factor into 2 pieces here. So let's do the easier one first, in my opinion, the difference of squares. So taking the square root of this will give us x on each of them. Taking the square root of 4 will give us 2 on each of them. And the fact that this is just a minus will be plus and minus, and we're done with that one. Okay? We'll do the same thing here with sum of squares. Square root of x squared gives us 2x's. The square root of 4 gives us 2 2's. But here, because it's a sum of squares, we're still going to do the plus and minus, but because it's a sum of squares, we need those i's. So we have x plus 2i, x minus 2i, x plus 2, and x minus 2. This is the factored out completely part, and these are the x-intercepts. 0, negative 2i, positive 2i, negative 2, and positive 2. And yes, if you wanted to be a little bit more efficient and just do plus or minus 2i, plus or minus 2 on this one or any of the ones that we've done previously, you are more than welcome to.